Welcome to the 6th lecture on computational mathematics with Sage Math. In the next two lectures, we will be looking at loops in Python. So, whenever you want to do some task repeatedly, you want to execute some statement whenever certain list of conditions are satisfied, we use loop. So, let us start with for loop first. So, a general syntax for loop is given by this for variable in x colon and then list of statements. Again, these list of statements will be indented, and this variable is any valid variable name, and this x could be various things. It could be a list, it could be a tuple, it could be a set, it could be even dictionary. So, we will look at few examples. So, for example, let us say we have, let us say, for let us say variable k in, let us say, range 10. So, range 10 means it will give you 0 to 10. Suppose I just want to print what is I, what is k. So, what it is going to do? It will take value k in this set range 10, but range 10 is 0 to 9. It is a list. So, for each k it will print that element. So, first it will print 0, then it will print 1, then 2 and so on in one line, right. So, in each line you will print one variable. Okay. Now, this, as I said, this instead of range, if I make it, let us say, tuple of this, that means we are creating a tuple of numbers 0 to 10, and if I run this again, you will see that it gives you the same thing. So, this x can be list, it can also be tuple. How about suppose we make this as a set? If I make this as a set, then still it works same way. We will later on we will see it can also be a dictionary. Okay. So, basically we will be having this x as a list mostly, and we have to iterate over that list. So, here we had only one statement, but you can have multiple statements which is executed. For example, I say, let us say, print k, and also let us say I can say print let us say k square minus 4, sorry, k square should be double star minus 4. So, you can see here for each k it is first printing 0, and 0 square minus 4 is minus 4 and so on, right. So, this is a very simple for loop. Now, let us look at some examples how to make use of this for loop through examples. So, the first example we have already seen how to compute the amount received when it is invested under compound interest, let us say on some interest rate. Okay. So, suppose we want to print the amount received on an investment under compound interest every year for first 10 years. So, how do we do that? So, just recall that how we did this earlier. So, if the principal is, let us say, 20,000 and interest rate is 5%, and then we want to print the amount received after every 1 year. So, after 1 year, so that means that this year will vary from 1 to 10. So, 1 to 10, if I have to generate using range function, we have to say range 1 comma 11 and then colon, and then calculate the amount. This amount is principal into 1 plus rate divided by 100 to the power number of years, and years will take value 1 to 10, and then you just print the amount after so many years is given by this using f string. So, if I execute this, you will see that it will give you the amount received after 1 year as 21,000, after 2 years 22,050, and so on. Okay. We have printed 4 decimal places, that is why here you have dot 0.4 f. Okay. So, this is how you can make use of for loop in order to print all the amount received after every year. Suppose we wanted to print only after 10 years. Of course, for that we may not even need for loop, but in that case this print statement which you have here, you can push it outside this loop. So, let me just copy paste this, and let us insert one input cell after this. So, if I push this outside this for loop, then what is it doing? It is computing the amount after every year, and after end of this loop, once this loop is over, then amount is calculated after 10 years, and only the last one will be printed. What you see here, only this the last one will be printed, just you can see here, that is correct. After 10 years the amount received is this much, right. Now, suppose it so happen that in between you want to break the loop. So, for example, here we have printed for every years for 10 years. Instead of 10 years, if you want 20 years, you can put here 11 instead of 21, right. But suppose I want to take out the money after it has become doubled. Okay. I do not want to be too greedy, I want to invest only till the money becomes double. So, in that case we do not know how many years it will take. Of course, one can calculate number of years based on this formula. One can obtain a formula for that, but let us say we do not know how many years it is going to take when we invest under compound interest. So, what we will do, we will be using what is called break statement inside for loop. So, if you want to break a loop in between, whenever some condition is satisfied, one can use break. So, how do we do that? So, what you need to do is again the same command. So, let us say we do not know how many years it will going to take. So, we will run for, let us say, 20 years first, 20 years. So, let me make it 21 and the amount received, and then print that amount, and in case the amount exceeds or if it becomes greater than equal to 2 times the principal amount, then you break. So, again here you have colon and then followed by break. So, let us execute this. If I execute this, it is printing first year, second year, third year, fourth year, and so on, and after 15 years the amount has become 41,578, which is more than double of 20,000, and in the previous year 14 years the amount was just less than the double. So, this is how we can make use of break statement in order to break the loop at intermediate stage whenever some condition is satisfied. So, this is very useful. Okay. Let us look at some other example. Suppose we want to generate a random list of 20 integers, let us say one at a time, put it in some list, and these random numbers are from 1 to 100, and then we want to find their sum. So, it is like you generate one number, and then let us say one number is 5, next number is let us say 7. So, you add 5 plus 7, that is 12, generate next numbers, that is support say 51, then 51 plus 7, 51 plus 12 becomes 63, and so on. So, keep on doing this how many times? 20 times. So, let us see how we can make use of for loop for this. So, first we will use module random. So, import random, and inside that random there is a function called randint we have seen earlier, and that random integer we want between 1 and 100. So, first we generate a let us say empty list, and in that empty list we will keep on appending the number which we have generated. So, a is equal to random dot randint 1 to 100. So, it will generate one random integer between 1 and 100, and then you append this in a, and then at the same time you add this to s. Initial value is 0. So, so for example, s is 0 and it will generate first number. As I said, first number could be, let us say, 5. Then the list, now this list becomes singleton 5, and then s becomes s plus 5. S is 0. So, therefore, and a is 5. So, s becomes now 5, and it will continue till this I exhausts all the elements in this list, that is 20 times it will run, and at the end you print what is the list. So, the list is 70, 63, 31 and so on, and the sum of this number is 1112. Suppose if I run this once again, I will get different set of random integers list, and the sum will also be different. That is what you can see. So, this is how we are able to generate 20 random numbers. Instead of 20 random numbers, you can have 2000 random numbers and still run this. Okay. Next, let us look at another example. Suppose we want to generate a random number between 0 and 1. So, it will be decimal number between 0 and 1, and suppose if the random number generated is more than 0.5, that is greater than or equal to 0.5, then we will call that as a, let us say, head, otherwise we will call as tail. Now, suppose do this experiment 500 times and count number of times you have obtained heads and tails. Okay, so, this is just an experiment which you are doing. So, instead of tossing a coin, you are generating a random number between a 0 and 1. So, when the number is greater than or equal to 0.5, you assign that as a head, otherwise tail. So, this is a very simple way to look at. So, number of tosses is 500. So, that is 500, and let us say to begin with, number of head is 0 and number of tails is also 0. Now, run a loop k in this range tosses, that means it will generate 0 to 500, and then let us call the number as a coin, and this random number between 0 and 1 can be generated by using function random from random library. We have already imported random library, but it may be a good idea to import it again, because sometimes you may be running this you may be running this before or after opening this file, and you may not have imported. So, let me just call from random import random. So, now I do not need to say here dot random, I can only say this. Okay. So, I think there is spelling mistake. From random import random, and then what we are doing. So, call this number as coin, and in case this number is greater than or equal to 0.5, then increase head by 1, otherwise increase tails by 1, and then you can print what are the. So, if you want, you can print this after this loop. So, heads and tails. So, heads are 271, tails is 229. Suppose instead of 500, if I do this experiment 5000 times and look at how many heads and tails, this is 2481, this is 25. So, almost 50%, and that is if I increased to even bigger number of tosses and then see how many heads and tails. So, it will be almost close to 50%, and that is why the probability of heads when you toss a coin is 0.5. Okay. So, this is an experiment. Okay. Let us look at another example. Suppose we want to find the sum of integers between 1 and 100 both included, which are divisible by 2 or 3 or 5. So, all those integers which are divisible by 2 or 3 or 5. So, any two of these 2, 3 and 5, then add all this between 1 and 100, and also count how many such integers are there. Okay. So, in this case we can do using various things. So, what we are doing, we are again generating n between 1 and 101. So, that is, since we want to include 100 also between 1 and 101, and in case n is divisible by 2 or n is divisible by 3 or n is divisible by 5, then you increase the count by 1, and also s is equal to s plus n, and s is initial value of s is 0, initial value of count is also 0, and then let us print how many such integers are there and then find the sum of all these. So, there are 74 such integers which are divisible by 2, 3 or 5 between 1 and 100, and sum of those integers is 3782. Okay. Now, let us make use of break. We have made use of break statement in order to break the loop in between. Sometimes some particular iterate you want to skip, right. So, for example, in this case we wanted these things to be added, but any integer which does not satisfy any of these things we do not want to add. So, we can make use of continue statement. So, this is the same thing, we want to do the same task, but this time we want to add how many integers are there between 1 and 100, again both included, which are not divisible by 2, 3 and 5, right. We want to add the remaining ones. So, of course, one can we could have done this using this kind of if itself, but we will let us make use of break continue. So, again how will we what we are going to do? So, count is equal to 0, right. We simply want to count how many are there, but you can also add, and then in case the number is divisible by 2 or 3 or 7 or 5, then you skip that. So, continue will give you will skip when that iterate when this condition is satisfied. Okay. So, that is what, and if it is not satisfied, then you add count by 1 and then print all of them. Okay. So, here it is printing everything in a single line, and that is where we are making use of end is equal to empty single quote or double quote. This simply says that do not break the line. If I do not put this, then the numbers will appear one at a time. So, it is just printing all the integers, and at the end let us say we want to also count how many are there. So, you can print outside this, let us say print count, right. Since if I want all these numbers to appear in a single line, since there are not too many, then we can add here what is called end is equal to empty double quote, right. So, and the total is 26, the last one is the number is 26. Okay, fine. So, this is how you can make use of continue. So, break and continue are very important concept that can be used in a loop, in for loop in particular here. And so, what does break do? Break will break the loop at intermediate stage whenever the condition is satisfied, and continue will skip that particular step whenever that condition is satisfied. Okay. Now, many times see, when you are writing the loop, you are writing everything in one line and one line, etc. If you want to write everything in a single line, especially if you have some kind of compact list to be generated, you can use it as follows. So, for example, let us say we want to simply take all those integers between 1 and 101 with 1 and 100 which are divisible by 2 or 3 or 5. So, we can simply write in the square bracket, that is the list we want to generate, n for n in range 1 to 100, and when do you take that n? If n is divisible by 2, 3 or 5. So, then we have generated a list, and we can find the list length of this list and sum of this list by using function len and sum. Okay. So, this whole thing which we have done earlier could be done in single line. Okay. So, this is what we call list comprehensions, and this will generate a compact list. So, many times this is a very nice feature if you want to save time and space. Similarly, if I want, let us say, to print, let us say, all those integers which are co-prime to 100, all those integers which are co-prime to 100 between 1 and 100, right. So, co-prime is same as saying the GCD of that number with 100 should be equal to 1. Okay. So, two integers whose GCD is 1 is known as we call that those integers as co-prime to each other. So, we already know that there is a function called GCD in math library, in math module. So, let us import that function, and n is capital N is 100, and then we will generate, let us say, generate a list of all those integers k for k in range 1 to 101. And when do we take that k? If GCD of n and k is 1. So, these are the integers, and how many such integers are there? You can count by putting. So, let us say this list is p, and then we will say len of p. So, that is 40. There are 40 integers between 1 and 100 which are co-prime to 100. Instead of 100, if I put, let us say, 1000, and then there are 400 integers. If I put, for example, let us say 25, this is 25, there are 20 integers. Okay. If I have, let us say, some prime, for example, 29, what are integers which are co-prime to 29? So, it will give you 1 to 28. So, there will be 28, correct, right. Let us look at another example. Many times you want to use for loop inside for loop, okay, this is what is called nested for loop, right. We have seen we can use if inside if. So, nested if we have looked at, we can also use nested for loop. Let us look at an example. Now, in earlier example we saw how to find the number of integers which are co-prime to a given integers, right. So, now let us say we want to find we have given two so if you have an integer n, and if you look at the number of integers which are co-prime to n between 1 and n, these are called actually Euler-Phi function of n. Okay. So, what we want to do, we want to print Euler-Phi function for each of integer between 1 and 20, right. So, how many integers are there which are co-prime to 1, 2, 3 and up to 20. So, one loop will be to generate how many integers are there which are co-prime to a particular integer k between 1 and 20, and another loop will run, that is outer loop, which will run from 1 to 20. So, this is a nested loop. So, what again, let us import GCD, though we have already imported, and from 1 to 20 is what we want to print. So, this for loop will be for each integer between 1 to 20, we want to generate how many co-primes are there. So, the start the number of co-primes to be 0, that is count, and then run these for counting how many integers are there which are co-prime to this. We could have also used here list comprehension, that the one which we did, and then print for each one, right. So, it says that phi of 1 is 1, phi of 2 is 1, phi of 3 is 2, phi of 4 is 2, and so on. So, that is a list. We have used nested for loop inside a for loop. Okay. So, let us look at another example. Suppose we want to write an user defined function to check if a positive integer is prime. Okay. So, how do we do that? So, let me call this function as is prime, and if the prime starts from 2. So, if anything which is less than 2 you return false, if n is equal to 2 of course it is a true statement. If n is divisible by 2, again it is not a prime, so you just simply return false, and then otherwise you check k for k between 3 and this is actually you need not go up to all the way up to n. It is good enough if n has a divisor, that divisor will be less than equal to square root of n. So, if you can check up to square root of n, then if you cannot find up to square root of n, then you cannot find it later, and that is why this runs from 3 to square root of n. So, n to the power 0.5, and then if n we take as, let us say, some square integer, then square root will be an integer, but otherwise it need not be integer, and that is why we are making this as an integer, and then you have to go up to exactly up to a square root n, and then you need not check the even integers, that is why start from 3 and increase by 2, and in case n is divisible by 0 you return false. If none of these things are true, then you print true, return true. So, that is the function to check if a given integer is prime or not. Okay. So, now let us make use of this. So, suppose we want to check various things. So, if I take whether minus 2 is a prime or not, obviously this is less than 2, therefore, it is not a prime. If I want to check whether 1 is prime or not, so again this should be false. If I want to check whether, let us say, 144 is prime or not, the answer is false. If I want to check, let us say 4, 9, 8, 9, 2, 7, 7, is it a prime number? The answer is true. So, if I give any arbitrary number is prime, and some arbitrary number, let us say it ends with 1, the answer is false. Okay. Right. So, now suppose we want to write a Python program to find the number of primes between 2 and n for particular n. So, how will you do that? Already we have a function called to check the function whether the function is prime or not. So, again we will make use of list comprehension. So, I am just giving the name of this function as prime pi, and the argument is n, and generate all these primes between 2 to n, right. So, p for p in range 2 to n plus 1, when you take that n, if it gives you value true, if is prime, value is equal to 2. So, if this is true, then it will take p. So, it makes a list of primes and then return the length of this. So, that is how you can find number of primes, and suppose we want to find out how many primes are there between 2 and 200, the answer is 46. Let me give you another example. Let us say we want to approximate pi using what is known as Monte Carlo method. So, this method is very simple. The way it works is that you for example, you take a unit square, let us say, and inside that make a circle of radius, let us say 1, and this circle is, let us say, centered at 0, 0, and then what you do is you generate some large number of random numbers, random points. So, each point will have coordinate between 0 and -1 and 1, and then count how many of these points are inside this circle and how many points are outside this circle. If it is a unit square, its area is 1, however, the area of the unit circle will be pi, right. So, the probability of a point inside the circle you can find out, and that is how you can approximate the value of pi. This is what is known as Monte Carlo method. So, instead of generating between inside unit circle, we can generate random number between 0 and 1. So, each point will lie in the first quadrant. So, we are taking the first quadrant of the circle, and then you take the unit I mean 1/4 of the unit square, that is in the first quadrant. So, what we do is, let us say we generate 10,000 points, again import the random number, and let us say start the count equal to 0. So, we will be counting how many integers are, how many points are there which are inside the circle. So, we are generating each coordinate x and y as random dot random and random dot random. So, x and y are random points between 0 and 1, and in case the x square plus y square is less than 1, then you say that it is lying inside the circle, that will increase the count by 1, and then look at the ratio, the total number of points which are inside the circle, inside this first quadrant inside the circle, divided by the total number of points, which was 10,000, and then multiply that ratio by 4, you will be getting that number, which is approximation of pi. So, if I run this, this is 3.1576. If I increase the number of points, let us say, then you will get closer to pi. If I further increase this, it may take more time, but you will get much closer to. So, if I will generate large number of such points inside unit square and count how many are there inside unit circle, then and take the ratio, multiply that by 4, that is gives you one way of approximating pi using Monte Carlo method. There are other ways of looking at it. Okay. Similarly, you can as I said in the beginning, the variable inside x, and that x can be dictionary as well. So, let us take an example of this. Suppose you have want to create a dictionary of 10 students with roll number 1 to 10, and for each student you have marks in 5 subjects, which is random number between 1 and 100, and then find the average of each of these students, and then add that average as another key to this dictionary. So, first let us import random, and then what we will do, let me just show you one by one, so that it will be easier to understand. So, first we generate a empty dictionary, and then next we generate a roll number, and roll number is again a dictionary which is empty dictionary. The value of that is empty dictionary, and then what do we do next? We are going to we will generate a the marks. So, marks is a key inside this dictionary, and that marks is a list of 5 random integers between 1 and 100. Okay. So, let us generate this. Now, suppose if I say what is D, you will see that we have generated a dictionary of 10 keys, and the keys are roll number 1 to 10, and for each the marks for each roll number, the value is again a dictionary. So, this is a nested dictionary, and the marks is a list of 5 integers. Okay. Now, what we want to do? We want to find average of each of these marks and add this to average. So, what we will do? So, we can run this, we can apply for loop inside this dictionary. So, for roll in D dot key. So, D dot key will give me 1, 2, 3 up to 10. Okay. So, it will be a list of 1, 2, 3 up to 10. So, for each of these, now you look at the sum of the marks. So, how do I access the marks? It is D of roll and the marks of that. Okay. So, these are the list of marks, and then take the sum, that is the sum of the marks of each student, and then take the average. Average is S divided by the length of the marks, and then you add D inside this you roll number, you create another key which is called average, and then add that value to the average, and let us run this, and now let us say if I ask for what is D, you will see that you have first roll number whose these are the marks and its average is added. So, this is one example in which we are iterating for loop over a dictionary. Let me just give you one more example. Suppose we want to print a pyramid of stars. This is an example of nested for loop. This is an example of nested for loop. Here actually we are using 3 for loops. So, the way it works is as follows. So, in this case we are taking height to be 10, height is the number of stars you want in this pyramid. So, we want that as to be 10, and then what we are doing is we look at how many spaces it will require. So, this is the number of spaces which will be required is 2 times height minus 1. So, that means total 19 spaces you are going to require, and then you for each row you have a for loop which is this one. This is for each row. So, total number of row is the total height which is 0 to 10 in this case, and this is the in a loop which will print actually the extra spaces. So, for example, in first row you have so many extra spaces, and that extra spaces is between 0 to m plus 1, where m is 2 times height minus 1. So, for example, if I start with this j is equal to 0, then that is the first row, the number of empty spaces that it should print first is going to be 9. So, this is 20 minus 1 19, 19 plus 1, that is 20. So, it will print 19 empty spaces, and then next loop is you are printing star, and so this is k is varying between 0 to I plus 1. So, as you increase the row, the number of stars will keep increasing by 1, and that is what is happening, right. And then you print an empty line, that is the new line. This is for the line break, and then you decrease m by 1, and then if you run this you will get this. If I give you for example, star and some space here, you will get one extra space. If I give one space in the beginning also, this is going to what is going to happen. Okay. So, right, and you can generate this pyramid downwards, you can generate a diamond kind of thing also. So, this is a very nice example of nested for loop. Okay. So, at the end let me leave you with some simple exercises. So, the first exercise is going to be write a Python program to find nth Fibonacci number, and nth Fibonacci number is defined is given by a recurrence relation fn plus 1 is equal to fn plus fn minus 1, and where you start with 2 initial values, f0 is let us say 0, f1 is 1. So, this is what you call nth Fibonacci sequence, and in case you take the ratio of fn plus 1 divided by fn and increase n to the large value, then that ratio actually converges to a very famous constant called golden ratio, which has lot of applications in nature. So, what we want to do is you generate the ratio of fn divided by fn plus 1 between let us say 1 and 50. For n is equal to 1 to 50, you generate this. So, first create a user defined function for Fibonacci sequence generating n Fibonacci number, and then print this golden ratio, and you will see that this golden ratio, this number as you increase n, it will converge to a particular value, which is what is called golden ratio. Next exercise is write a Python program to generate n points, let us say p1 to pn, which are equally placed on a unit circle, right. So, on a unit circle you generate n equally placed points, and you can any points on the unit circle is of the form cos theta sin theta, where theta is the angle that the point the line joining the point and the origin makes with positive x axis. Okay. So, you have and hence you find the perimeter of the regular n-gon with vertices p1 to pn. Okay. And as you increase this n, you will see that that regular n-gon will become like a perimeter of a circle, and so that this is another way of approximating the value of pi. Okay. The next is verification of these two identities, which is sum of NCR for r going from 0 to n is 2 to the power n, and the next one is sum of NCR into M C k minus r varying from 0 to n is equal to m plus n divided by n plus n c k. And the last one is use sample function from random module. So, this sample function will generate a random sample. So, if you have a list of 20 numbers and if you want to take take random 10 of them, you can make use of this random function. Okay. So, use this random function to generate a random number between 1 and 6, right. So, it is like a throwing a die or two die, and the random number which you get is the value on the face. Okay. So, this can be thought of as a number of faces when two 6 faced dice are tossed together. Repeat this experiment 100 times, right, and then count how many times the sum of the number of the faces of the both the dice are more than 8, right. So, 2 dice you are throwing together, and that is why you are generating 2 random numbers between 1 and 6, and then repeat this experiment 1000 times and count how many times you have got the sum of the numbers more than 8, and hence you can also find out the probability that the sum of the numbers on the two faces is more than 8. Okay. So, these are the simple exercises. Of course, we will be posting you the solution of these things, but they are actually fairly simple. I am sure all of you will be able to write a program for this, and so spend more time on working on these things, because that will also teach you for loop and nested for loop, etc. Okay. So, next time we will be looking at while loop, and we will look at so in case of for loop, we know how many times in the beginning itself it should run, except that when we are using break statement, and in while loop that is not the case. While certain conditions are satisfied, you can run this loop. Okay. So, thank you very much. I will see you in the next class.